All right, we're going to talk about parallel lines, proportional parts, and similarity. So let's get started here. So the triangle proportionality theorem says if a line inside the triangle is parallel to one side of the triangle, then it separates three sides into segments of proportional lengths. So what this is saying is AB and BD is proportional or equal to AC over CE. So you could also read it the other way as AB over AC over BD over CE. So either one of those works. So we're going to use that information and we're going to find the value of X. So for this first one, this is a little tricky because it doesn't tell you. We need to know these parts. I need to know this part and this part. I need to know this part and this part because your parallel lines are here. And that's what that little triangle means, is they're parallel. So first I have to figure out what that section is, and then I have to figure out what this section is. So let's go ahead and get started. I know that the total is 45. So to find this part, I'm going to go 45 minus 5x. So we're taking 5x away from 45. And then this part is basically 36, which is your total, minus 20, which is 16. So now that we have those two, now we can start setting up our proportions. So we're going to take 45 minus 5x, and we said that is proportional, so we're going to keep that to the side of 5x. So we're going side to side, so this guy to that guy. And then we're going to equal it, so it's to 16 over 20. And then remember, we got the 16 from here, that's this length, and then the 20 is this length right here. So we're basically setting up the proportion as side to sides. All right, now let's go ahead and let's solve. So remember, we're going to go ahead and multiply across. So don't forget, put it in parentheses. I'm going to erase that, it's horrible. Okay, so then you're going to get 900 minus 100x so add 100 oops, forgot the x's, and go 900 equals 180x. Divide both sides by 180, and you get x equals 5. All right, and so that's all you have to do. So remember, just set up your proportions. The tricky part here was you had to figure out what that side was, and you had to figure out what that side is. All right, and then that's your answer, is x equals 5. Now on this next one, I set up the parts for you. Now how you set it up is up to you if you want to do side to side, so you could do this over that, or you can go this over that. So however you want to do it, I did it this way, where 14 over 8 equals 17.5 over x minus 1. So you're going to do two things. You're going to find x first. Then once you find x, you need to find this segment by plugging x into here. So go ahead, you're going to continue, or you're going to find that one. All right, then you have the converse of the triangle proportionality theorem. So converse is basically, when you see the converse, you're just basically trying to prove, hey, is BC parallel to DE? Before, they told us it was parallel. Now we're asking, is it parallel? Well, it is parallel if it separates the corresponding segments proportional lengths. And if it is, then we know that, yes, that's parallel. All right, so I have AB over BD. We said that equals AC over CE. Or you can do the other way, AB to AC and BD to CE. Either works. Just make sure the question you want to figure out, if it works, it's parallel. So let's look here at this one. I set it up for you. So we said AD is 15. Oops. There we go. All right, so we said AD is 15. That's given. DB is 12. AE, so we didn't have to do any subtracting to find any lengths, so this is pretty straightforward. All right, so now we need to set up our proportion. So we did this as side to side, so 15 over 12. And we said that's equal to 10 over 8. And when you cross multiply, you get 120. 120. And since 120 does equal 120, this is true. So that means, yes, BC is parallel to DE. And that's your answer. So we're basically proving that these are parallel lines. All right. So I set this up for you. You are going to do subtracting because you do need to figure out what this part is. And then you are going to do some subtracting because you need to figure out what this part is. Then once you set that up, do your proportions. If it's true, it's parallel. Parallel lines. False statement means not parallel. All right, so you're going to go ahead, you're going to set this up, and you're going to solve to see if it's parallel or not. All right, here we got a couple things to think about while we are doing this. So, for the first part, we have the 3 parallel line theorem. So if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionately. So in other words, RS over ST is equal to XY over YZ. So it's proportional. And you could also set it up the other way. So we are given that those are parallel. All right, so that's the 3 parallel line. And then you have this also, which says if 3 or more parallel lines cut off congruent segments of your transversal, then they cut off for every transversal. So basically, if these are all congruent, then you know it's going to be congruent there. So the same distance, equidistance. All right, so let's go ahead and let's get started with some of these down here. I started this one for you. All right, so for this one, we have 3 parallel lines. And then we've got a transversal and a transversal. So if these are equal here, that means that these are equal to each other here. So I'm going to go ahead and I'm going to write that in. All right, now that we've got this set up, now we can figure out what to solve for x first. So I would solve for x. And the reason I would solve for x first is because I know this is going to be equal to this because these are congruent. Okay, so that's why I did 2x plus 2 equals 3x minus 4. And then when you solve for x, you're going to get that x equals 6. So this is 6. All right, and then for this next part, you're going to do the same thing. This line and this line, they're both congruent. So that means you're going to equal those two. And let me show you a little math magic here. All right, so you're going to set this up. This is equal to that. Now I'm going to clear the fraction by multiplying everything by 8. When I multiply everything by 8, I'm going to go ahead or sorry, when I multiply it by 3, I said 8, my bad. When I multiply it by 3, your denominators are going to cancel, and you're going to get 8y. And then you distribute that here, plus 21. And then you're going to distribute that over here, and you get 15y. And then now, no more fractions, so now go ahead, subtract 8y. And you're going to get 7y equals 21, divide both sides by 7, y equals 3. Now, we've got x, we've got y, we follow directions, we're good to go there. All right, this one, make sure you write this as x, it's kind of blurry on the paper, so just to make sure you understand that. Now, this one does have a tricky part here, because first off, these are all parallel lines, so that means that if this is x, these should be equal. So just make sure you're watching this, that those two should be equal, and if those are equal, then those two should be equal to each other. So just remember, it gave us a total of 77. So to find this portion, you do 77 minus x, gives you this guy right here. All right, so your hint is set up a proportion, solve for x, and if you did that correctly, you should have gotten x as 42. All right, now angle bisector theorem. This is the last part for this. And this is saying an angle bisector in a triangle separates the opposite side into segments that had the same ratio as the other two sides. So again, A over C is equal to B over D. And then we're going to take that and we're going to find x on this example. So here's your bisector, and you know that because these are congruent to each other. So you're going to go 20 over 7, because that's one side of the triangle, is going to equal 24 over x. Cross multiply, and you're going to get 168 equals 20x. Divide both sides by 20. You are going to get a decimal, 8.4, but that's okay. And that is solving for x, and that's all you have to do. So for this one, your angle bisector is right here. So you know this angle is equal to that one. So what I would do is set up your proportion as 12 over x plus 2 equals 8 over x. Cross multiply and solve for x. So if you did that correctly, x should equal 4. So remember, you've got your triangle proportionality theorem, the converse, your three parallel line theorem, and your angle bisector. Those are all proportional, so make sure you're following the directions and the rules on that one.